I want to show in this session is how to create how to visualize a point cloud like this in Blender. This point cloud corresponds to a set of image slices, and if I now move the camera, I set up a constraint here, so I'll be setting this up from scratch again in a second, but this is what we're going to do. First, we can have this, which is a scientific set of image slices that I got from here. I'll be putting a link to this in the description. So I downloaded .tiff images from here. I sent them through Touchdesigner to get the scale down. So if I look at them, if I look at them right now, here, image sequence, we can see they're scaled way down. Each one is only 33 kilobytes. So the quality is really bad, but I do this so the setup in Blender is a bit easier. I spare myself 2 nodes or so I can just directly plug the image in, so it generates a point per pixel of the image. So my other example for what to use this for is just this fun thing that I created by instancing spheres in Touchdesigner and having a camera, an orthographic camera, cycle through, where is this? I have to show this on the camera. So the camera's near and far planes are cycling through values. So the reason why that's not updating, okay, good. Everything is working as expected. So I'm instancing these spheres, coloring them randomly, and these are just cross sections at certain slices. I exported this as an image sequence, PNG, frames 0 to 100, just so it looked good. These are the images I obtained. So the Blender workflow that I'll show in a second works for both of these applications. Having this, why ever you'd want to do something like that doesn't matter. And these scientific images. Okay, so if anyone wants to know how to do this exactly, happy to show it, but this is not the focus of this session. Okay, so let's hop into a new session right here. So let me save this one quickly. Save. I'll just put this right here. Good, so now we can hop into a new file. So I have my default plane right here. And let's start by right-clicking here to do a vertical split. This is just the default geometry nodes window. I set up a new network right here, and I'll switch this one to image editor. What are these called? Well, this window, this area. Set this area to an image editor, and I'll open the image sequences. So I'll start off with the sphere slices. I'll press A, so it selects all of them. Open the image, so then in the image editor I can press N to to see the image sequence, you see it, recognize it automatically as an image sequence. And here we have options to set this, for example, to non-color for other workflows that might be pretty similar. And in this viewport, we can look at the values. You can see that the alpha is correctly. I limited it. I limited the alpha in Touchdesigner to either 0 or 1, so all of this is getting correctly recognized, and these are solid, almost solid colors if you look at them. Yes, actually. So I thresholded those so they're, yeah, the different solid RGB combinations. Okay, so this is useful. Now what we can do is, if we Shift A, select an image info, we can start by, so for debugging, this spreadsheet view is usually very helpful, but we won't be needing it today, so I'll just get more space right here. And we don't even particularly need this as well, so we can also get rid of this right now. The only thing we have to check out is that our image sequence was correctly recognized, that the frame range is correct. So I'll set this to 0 to 100, so I can just play and press space while in the image editor, and it will play through the image sequence, and everything works fine. If I go all the way to the right, there's no looping back, which can happen, and we can check where it starts. So it actually starts with frame 0 at frame 1, and then we have frame, well, 99. Of course, this is the last one if we start at 0 and have 100 frames. Okay, so all of these images are, okay, they're 200 by 200. Good. This is important when we look at what dimensions our resulting cube should have, what dimensions each voxel should have, even though we're displaying a voxel as a point. Okay, well, let's get started. I know that this is, I could be way quicker with all of these things, but still, I think I can add my own mustard. Okay, so I'm choosing to hook this image info up to a group input, which will just be image, and I can choose our spheres image here before hooking it up. Okay, so this will correspond to the resolution of our image. So if we hook the width and height of our image up to a grid, then we'll have exactly the up to the vertices input of our grid, we'll have exactly the amount of points as in the image. So if we already do a mesh to points on this grid and bump this up to 10 by 10 meters because of the default radius, we could have also put that lowered that point radius, but here this is a point per pixel already. Okay, so this is a fresh, this is a good start. Well, what do we have to do now? Now we have to obtain layers. How do we do this? And because we will want to plug the color of this image, we will get the color by getting by plugging this image input into an image texture, and then using the grid UV plugged into the vector of the image texture, we can color these points. We can already do a demo of what this looks like for a single image. So so you'll have something to so we'll have a proof of concept early on. So I'm storing a named attribute called color, setting the type to color, and then if we go to the material properties, we can add a material. I won't give this a fancy name because we'll only be adding basically one material in this session. So I'm already setting the material, I'm storing the named attribute called color, I'm plugging the UV in, and if I change this to material view, go over here, search for attribute, type in color, and plug the color in here. Wow, okay, so this is our first image. So again, if we look at the spheres image right here, why is it not showing? There's no reason not to show. Press N again. Well, yeah, okay. So this is basically, yeah, this is exactly what we're showing on here, because I set the frame. Well, here it uses frame 0. Okay, good. So all frames have the same resolution. So it could be important to also iterate over this if the images have different resolutions, but that's not our case here. So we can carry on. So how do we do this? How do we now stack this? So the thing is, you can't just instance this grid and try to plug in the index along a line, for example. So the thing I tried at first was adding a curved line and then somehow using the index along this curved line to specify the frame. But the problem is, I think even if I plug this in right now, this is not a valid connection. So the image texture node does not accept arrays, as I understand it. So we will have to use a repeat zone for this. So for me, this was the first, one of the first times using a repeat zone. So how can we quickly get this going so that we see the same thing but have it running through our repeat zone? So now everything will disappear, and I can add a join geometry right here, plug this one in again. So now we see it. I can't even recommend a good tutorial for these repeat zones, but have a look for some. So this repeat zone, I can add a group input for this iterations input because this, if I press N, I'll see iterations here. I can call this layers. So how many layers do we want? Okay. And then if I choose to, I can do this right here. If I choose to set the position, so here, if I set the position, I can set an offset. So right now this iteration is just going from well, I guess it's just reaching 0, but I can already plug this. I can already type in 10 here, and if I multiply the iteration with, well, with a certain value, this can be the distance between the layers that we're making. And if I now make a vector from this, I can search for combine z and plug this into the offset, and this will already create those layers. I can bump this down to 0.1, for example. You can get real scientific about this. You can plug in real values, because if you look for tissue slices, for example, you can find which which height one slice corresponds to, basically. And with my Touchdesigner setup earlier, I guess you can also do the same thing, that you look at what your exact height of each slice is. Yeah. Okay. So now we also have to plug this iteration into the frame, and we'll see that we're already getting a different image. For this particular setup, where we have an alpha channel, we can, which is the easiest, you can plug in the alpha in. I can quickly do this. You can plug in the alpha, which comes from here, into the alpha, and we will only keep the points. So we will only shade. Only the points that have. Points will be shaded according to their alpha. That's okay. That's correct now. But the thing is, the other points also exist. For this setup, we only want 100 points, but we're generating 1,000,000. This is not. This is not a sensible approach. So here we're getting an idea of what points exist and which ones we want. So right here we can plug in delete geometry. So I'll do this after the store named attribute, so everything will disappear. We can take this alpha, we can compare it, do an equal compare. The default is 0, so we'll be deleting all the points that have an alpha of 0, and well, this looks good. So because this doesn't look so clean, we can see that right here. I have to take this away. Okay, so now we have another interesting thing, that some of these points aren't colored correctly. So that is because our grid UVs for the points according to 0, 0, 0, 1, 1, 0, 0, 1, and 1, 1, they're at the edges. So all of the points, so basically only if you have an odd number of an odd numbered resolution, only the middle lines will be at the correct UV, but the ones at the edges will be misplaced. So these vertices at the edges are looking on exactly the edge. So the point in the corner will have the UV 0, 0. But the thing is, we want the value of the pixel in the corner. So we'll have to do an adjustment of this grid UV map. So for this, we will need the width and height of the image, and the UV map will map this vector to a new range, and I'll already take the width will be using a divide right here. But what I'll do is I'll quickly plug in the height into here, already switch this, and now we can select these three, the map range and the two divides, and make this a new group. So now it will automatically set everything up the way I want it. So we can press tab to go in and out of these group nodes. Okay, so for a bit of background, I think in another video I've already shown how to correct for this UV mismatch. Yeah, in my first long format tutorial, I did exactly that, but I think I'll show this one more time in this workflow. So if I get a Touchdesigner window back, I encourage anyone using Blender to maybe also get into this software, because it can always help. So if we look at the U and V, it says 0.002 along both axes, and these are the values we want for our edge cases. So for the upper right corner, it will be 0.998. So how do we get these values? You can copy them over. So for this example, this might even work. Let's try that right now. So we're trying to go from 0 to 1 to a minimum of 0.02 and 0.002, and to a maximum of 0.998 along both of these axes. Okay, yeah, so this does look better, but a problem that can arise here is that Touchdesigner is rounding these numbers, and just carrying them over won't lead to perfect results. So we'll be calculating them anyways. Now I remember one thing we have to look out for is we can clip the image, so we don't have to. So we see this is enough. So I guess you can scroll 2 minutes ahead if this suffices. So now we might have exact pixel values. I guess if we're using this resolution 200 by 200, the values are fine, but that won't always be the case, and you don't always want to go through Touchdesigner to calculate those values. So if we divide 1 by these by the height and width of our image respectively, we'll get the width of 1 pixel. So is that completely correct? Well, we'll see in a second. We might have to divide 2 by our pixel width. So if we now gotta combine XYZ, so we'll be plugging this into here and another one into the 2 max. So first we want to plug this value directly into the from. because this will be a small value as soon as we calculate it. So now this is 0.005. That's not, so this seems correct. So this seems correct, yeah. Okay, good. I guess the image is smaller than that. I don't know why it's... The images seem to be larger than I asked for. Ah, okay, so yeah, they are 200 by 200. Yeah. So I just want to make sure this is working correctly. Yeah, so I'm initially I'm concerned about this mismatch right now, that we're not landing exactly on, that our value isn't exactly 0.002. We'll just see where it goes when we hook it all up. Yeah. So what we'll also have to do is do 1 minus this value to get the values for the edges. So we'll move this one over. So do 1 minus this value, and here we'll see, okay, we'll have to hook this up for it to be calculated. Oh. Oh. Okay, good. Okay, so we're back at what we were looking at. So this does look fine. Well, this will do. So this is, I'm pretty sure this is the calculation we have to do. I'm just yeah, I have to say I am a bit confused why this is not working right now, but never mind. Well, we have our setup now. So now we can bump up our layers. So this is an expected effect if we look closely at what's happening in Touchdesigner, but if we bump up our layers, we'll see, looks good. We can bump it up to 100, and the computer is managing it, especially because we're able to delete all the points that are not being used. Okay, so this is our first full result. So the next thing we can do is, if we duplicate this, I'll call this one spheres. I'll duplicate it and call this one tissue. So if we hide spheres, go into tissue and open another image sequence. If we go out, I have my image sequence in here. If I upload this file, I'll embed the sphere slices, but these tissue slices I won't be including, but still, for hooking tissue slices up, so we see it immediately works. The one thing we can do is scale our grid according to the aspect ratio of these images. So we see it's 114 by 160 by 160, so we can make this 16 and 11.4. So now this will have the correct aspect ratio. Good. That's the first start, and I'm pretty sure we'll have to bump this thickness way down. So I'll just eyeball it that it's closer around 0.02. And for the shading of this tissue slice, we can do something. We can color it. So I posted something the other day on Reddit where I colored this purple. I can show that. So what we can do here is, well, this won't do anything, plugging the alpha in here because the alpha is solid, but we can plug the color into the alpha. So here the darker sections will have a lower alpha. So I think this looks quite nice. And for the rendering case, we can set the emission to 1 and plug in the color so that everything will shade without lighting. I really like doing that. So to get our renders into our project folder, I'm setting this to a double slash, but just to render an image. So an important, yeah, that would be hilarious if it crashed on me. No. Okay, of course, the camera placement makes no sense. Still, when setting to look out for, I'm pretty sure it has helped me these past iterations, is simplify in the render properties. Okay. So the other thing we can do when imaging these point clouds is just see how it looks when we render with just one sample and go up from one sample. I dare say, trust me. So the next thing we can do, if we want to make a nice visualization here. So I guess we're done with the setup of this point cloud, but still, why not? Let's go an extra step to animate our camera movement. So I'll add a circle, I'll press GZ to move it to where I see it. I'll scale it, just eyeballing the scale according to the current camera placement, which I guess is not perfect if we look through the camera for a second, but still we can check that out in a second. Okay, so I'll move the camera back to the origin by pressing Option G. Okay, so there we see the camera, and I'll go into the constraints, add a follow path, and the thing is, the circle I added has to be a curve circle, so a Bezier circle, but still GZ, move it up, scale using S, perfect. Select the camera again, select the Bezier circle, so now it's on this circle. Next thing we can do is add an empty, let's do plain axes, move this to where we see it, and we can add a track to, make it track to the empty. So now if we look through the camera and move our empty back down again with GZ, we'll see we have pretty good control over what our camera is doing. I usually, what do you call it? I usually stick to this setup. So now if we move to the 0 frame, we can go into the constraints, keyframe the offset, go to the end, and set the offset to 100, which is basically a factor along the curve in percent, and we'll have a looping animation around this tissue slice. So we can go on the empty again to fully frame this, or at least frame this more. GZ, easy peasy. Okay, perfect. I guess this is good for now. So if we don't want it to ease in and out, we can quickly go into a graph editor to edit these camera keyframes. We can select normalize, select both these points and set the interpolation mode to linear. So this might be a bit better. So now all you can do is make the animation longer. So this will actually easily work. And then if we select this point, well, I don't see an easy way to adjust its value. So well, help. Yeah. I guess I have to click on the point exactly. So yeah, so here I can set the keyframe to 200 and 100. So at frame 100, I want to have the value 100. So now it's perfectly looping this, and the render times are real quick for these point clouds. Yeah, so that's a cannot save. Okay, so for actually rendering this out, it's very important to, if you choose to have a dynamic or relative path like this, you have to name the file, the blend file, and then if you render, it will go quite quickly. Okay, so I guess the video capture in OBS usually doesn't work as soon as I start rendering. Okay, so I just have to press restart capture in OBS. Interesting. Well, then I seem to be able to go back to my file as soon as it's rendered. So this might look a tad bit different. View loop. All right, beautiful. So I think this is a pretty good result already. You can see some of the underlying 3D structures. This is rat brain. Anything I think got lost at the end of my first recording was that I added a color ramp to the emission color. Yeah, who knows if that's the best way to do it, but for the interior preview we'll also have to plug it into the normal color input. Yeah, okay. So I guess that will be it. Cheers.